A huge thanks to Brian for sponsoring this video. Good morning, fellow mathematicians. Welcome back to another video. So you sit at the doctor's, you wait in line, browse a bit through Twitter, and suddenly this right here pops up. And you think to yourself, hey, looks pretty cool. I should give it a shot. So you make 2 to 3 notes and suddenly the doctor says, come in, mate. It's your turn. And then you need to stop. And then you think to yourself, hey, that would be a cool improvised session. Now, it's a semi-improvised session today because I actually thought of 1 or 2 things I could do, especially the placement in the coordinate system of the structure that you can see here. So the main mission today is to find the radius r. The problem was without any caption whatsoever, just this post, and I think it's gonna make for a good video and a good problem overall. Try it out for yourself, and when you're done, keep watching the video for hopefully the solution. We'll see about that. By the way, this video has been sponsored by the wonderful people over on Brilliant. More information at the end of the video, so stay tuned. Their services are absolutely amazing. I love what they do, so check it out too. And now we are going to dive right in. So I had a few ideas in mind how I could place this analytically in a coordinate system, the structure. And my first hunch was actually to not place it in an origin that you would expect, but rather by using the theorem where you take the chord inside of a circle, and when you halve the chord and put a perpendicular to it, it's going to run right through the middle, giving you the radius kind of. This was my idea, but that would probably turn into a mess and we wouldn't make use of the 60-degree angle that you can find here on the 12 length line segment. So I had a different idea in mind because if we take a look at the equation of a circle, the equation of a circle is given by x minus x naught squared plus y minus y naught squared is equal to r squared, where r is the radius respectively and x naught and y naught are the coordinates of the center of the circle. Now, we can actually get ourselves a fine equation by putting it like this. This was my thought process. We have our coordinate system here. And since this chord that we got here is 3 units to the left-hand side and 4 units to the right-hand side, I thought about putting the point dividing this chord right here right into the origin. And basically we have -3 here and 4 here, and this is going to be our circle in some kind of way. So our circle is obviously not centered at the origin, but this right here makes it actually very nice to put into this equation because we have 2 points given. The point P1 is given by -3 and 0, and the point P2 would be given by 4 and 0. Now what we also have is this 12 length line segment looking like this, stemming from the point in the origin. It's 12 units long and it goes down here by 60 degrees. Or I should rather say -60 degrees. If we take a look at this analytically, it's a function which goes downwards. It's a falling function, monotonically decreasing. So this right here is 60 degrees, or more strictly speaking, -60 degrees. And yeah, I think this should make a good starting point. This is where I had to stop, but I hope it turns out nicely. So let us put our numbers or our points P1 and P2 into the circle equation and see which system of equations we are going to get. Obviously, since they are centered at or the y coordinate is 0 here, we would end up with this y coordinate missing right here. So -1 naught squared on both equations, which is just 1 naught squared. So by putting this into here, we get -3 minus x naught squared plus y naught squared is equal to r squared. And the other one, vice versa, is basically the same thing. We have 4 minus x naught squared plus y naught squared is equal to r squared. If you were to subtract those from one another, that works out nicely, then we get a homogeneous equation. We are going to end up with 0 being equal to, because this and that is going to cancel out. -3 minus x naught squared. Let's make it easy on us. That's the same as 3 plus x naught squared. And then we subtract this from this, minus 4 minus x naught squared. we could just multiply everything out. That's a binomial formula, but it's also the difference of two squares. It probably really doesn't matter when it comes to the algebra in and of itself. Let's do it the cool way and let's use the difference of two squares. So this ends us up with 3 plus x naught plus 4 minus x naught times 3 plus x naught minus 4 plus x naught. This net is gonna cancel out, giving us overall, this is just 7. So 0 is equal to 7 times, this is -1, 2x naught minus 1. Now this right here can only be equal to 0 if 2x naught minus 1 is equal to 0. And that means that x naught is equal to 1/2. Okay, so our circle's equation is going to turn into x minus 1/2 squared plus y minus 1/0 squared plus r squared. Okay. That seems reasonable, 1/2, okay. Probably also does make sense that it's 1/2 shifted to the right-hand side, because we have, if we were to shift it 1/2 to the left-hand side, we would have negative 3.5 and 3.5 on the right-hand side, giving us this this vertical center piece, basically. Yeah, that does make sense. I could have thought about this beforehand, I suppose. Now the harder part is probably finding out why not. We could, for example, just plug another point in and get us an equation which includes y naught once again. Like this one right here, we already dealt with this. But putting both in doesn't make any sense, because y naught in the process is going to cancel out overall. So let us just get ourselves another equation which we can most certainly use later, because we are going to get a third equation using this piece right here. So we get 1/2, so 3.5. This is 7/2 squared plus y naught squared is equal to r squared, or 49/2, 49/4. Okay. Now let us deal with this one right here, which is gonna end us up in a point on the circle's outer arc. Let's call it P3. Let's not use x and y, that would be confusing. Let's use a and b. Okay. Now we could get ourselves an equation for a line and search for the intersection between our circle's equation and this line segment. The line segment would obviously be y being equal to, that's a proportional function running through 0. It's negative most certainly, because it's strictly decreasing. And then we would have the tangent of pi over 3 times x. Okay, tangent of pi over 3. Is it square root of 3, or is it 1 over square root of 3? I think it's square root of 3. If I mess it up, then it is what it is, I suppose. That's equivalent to saying L is equal to, I hope it's equivalent, y equals to negative square root of 3 times x. Now, since our point P3 is a and b, we also get, when plugging this in, that b is the y coordinate. B is equal to negative square root of 3 times a. Which does make sense, because if we were to also do a right triangle projection in here with a and b here, then we would have, obviously, that the square root of, no, not the square root, tangent of 60 degrees is the square root of 3, is equal to b divided by a. Yeah, exactly. So that does check out. Okay. How is this important? We still have the 12 units as the side length given. Okay. So we can use Pythagoras, obviously. we have 12 squared is equal to a squared plus b squared in this right triangle, but b is the same as negative square root of 3 times a. So this right here is 144 is equal to a squared plus negative square root of 3 times a squared, which is plus 3a squared. That's convenient. That's 4a squared, and by taking the square root on both sides, we are going to get 12 is equal to 2a. Or in other words, a is equal to 6, and we are going to get that b is equal to negative 6 square root of 3. That looks like a bit of a mess, since those are x and y coordinates that we would plug into the circle's equation because it lies on the outer arc of the circle. We get this negative 6 square root of 3 in here as the y coordinate, but using the binomial formula, we still have an irrational number left at the very end. I hope you see where I'm getting at, because the y naught is just an unknown variable, so we end up with something 2 times 6 square root of 3 in the middle. Let's see if this can check out. Let's just see. If we plug this into the equation of the circle, we get a is equal to 6. So we get 6 minus 1/2 squared plus negative 6 square root of 3 minus y naught squared is equal to r squared. This right here is 5 over, no, it's 5.5, which is 11 over 2, but squared, which is the same as 121 over 4. Now this part right here, if we factor out negative 1, this is just all positive, is 36 times 3, which is 108, plus, yeah, and then we get 2 times 6 square root of 3, which is 12 square root of 3 y naught, plus y naught squared is equal to r squared. Okay. Okay, let us write everything out and see what we are going to get. Maybe it turns out nicely. So we get 121 over 4 plus 108 plus 12 square root of 3 y naught plus y naught squared is equal to r squared. But we also have our other equation, which is this one right here. So we have 49 over 4. This right here is a system of equations. So 49 over 4 plus y naught squared is equal to r squared. Once again, by subtracting, we get a homogeneous equation. That's going to cancel out, giving us overall 121 divided by 4 minus 49 divided by 4. All of that is gone. We have plus 108 plus 12 square root of 3 y naught is equal to 0. Okay. Now let's do some calculations. 129 minus 49 is minus 50. We get 72 over 4. 72 over 4, that's not 20, that is 18. Okay, so this part right here is 18 plus 108 is 126 divided by 12. Okay, so we get 12 square root of 3 y naught is equal to negative 126. I mean, 120 is divisible by 12. We get a remainder of 6, which equals 1/2 then. So 21 over 2. 21 over 2 square root of 3, but with a negative sign. So y naught is equal to 21 over 2 square root of 3. You could probably rationalize this to square root of 3 over 3, so that is 7 times square root. This gives us a 3 down here, square root of 3 here. So this is 7 square root of 3 over 2. Okay, so the equation of a circle is now x minus 1/2 squared plus y minus, that's all negative sign, plus 7 square root of 3 over 2 squared is equal to r squared. We don't even need this equation anymore because we have other equations that we could deal with. We could plug this number into any odd equation. Let us just use this one because this has y naught squared. And now I can see that it doesn't matter if y naught is actually irrational because we squared anyways, and this should check out. So last but not least, to find out the radius, we have that r squared is the same as 49 over 4. Yeah, 49 over 4. Then we have plus y naught squared. The negative sign is going to cancel out. So we get 49 over 4 times square root of, no, not square root of 3. It's going to be squared, so times 3. And that is actually quite convenient because this is 1, 49 over 4 plus 3, 49 over 4, which is the same as 4 times 49 over 4. I can't believe it, that is cool. And r squared is equal to 49. Since r is a line segment or a length, it's defined positive, so r is equal to 7. And this does look like something that could most certainly be right because that's a nice number, I suppose. Didn't think that could work out like this with the irrational number, but it actually did. We would have been fucked if it would be x naught, then it wouldn't have cancelled out nicely, but that worked out nicely. So what is, yeah, doesn't matter. 7 seems to be the radius overall. I'm gonna later plug this into Desmos and see if this checks out. Just gonna see what the radius is and if this line segment of 12 is gonna fit. But maybe you got the same answer. Let me see in the comments if you also got it on 7. That's very cool. That's a very nice result. And I thank guys for watching. And if you want to see more mathematics that we did today, analytic geometry, calculus, analysis, whatever it is you want to see, then make sure to check out the contents of today's sponsor, Brilliant, who are kind enough to sponsor yet another video here on this channel. Main reason for me why I use analytic geometry at all times when it comes to geometry in general is that you can use coordinate systems and the structure to just move it around. See how it pans out on the rotation, translation, whatever it is, and just place coordinate somewhere where it's seriously useful for you. And as mentioned before, I tried out different constellations and this one worked out. You could use any old constellation, really doesn't matter. It's going to work out at the very end. But the way you put your coordinate system is going to matter extremely when it comes to the efficiency of you solving the problem. And this is where Brilliant could come in very handy. Brilliant is your source for some of the best online learning content that you can find out there on the internet. It doesn't matter if you want to learn the mathematics that we did today, physics, computer science, chemistry. It seriously doesn't matter. They have everything over on their website. Everything you could quite possibly think of STEM related that you would like to learn today on a daily basis, on the go, using their app, or at home, just using their website. Brilliant got you covered. And to get back to what I was saying, Brilliant has a unique learning concept which is going to make it easy for you to learn something new very, very quickly and very efficiently, like putting the coordinate system in a place where it's going to help you to determine the solution faster. Brilliant is going to give you an intuitive understanding of what you could do with functions and their transformations by using, for example, graphics that you can play around with your own two hands. Just take a look at any of those animations that I'm going to show you right now. What you're going to notice is they are not going to drag you through their courses with a lot of abstract stuff and a lot of math jargon all over the place. No, what they would like you to do is to just take this lever this graphic, play around with it, drag it around, see what the function is gonna do under transformation, translation, rotation. Really doesn't matter. Brian is extremely good at transferring the knowledge over to their users in a very intuitive and playful manner. And you should check it out today for you too by using my link here at the top of the description, brian.org/flammablemess. With it, you're going to get a 30-day free trial of amazing awesomeness. Try out the whole landscape for completely free of Brian. Don't take my word for it, just try it out and see if it's something for you. And if it is, if you feel like this could turn into a long-term relationship between you and the services, then definitely make sure to use my link entirely or use my QR code somewhere up here in the corner to get 20% of an annual premium subscription. It's an amazing deal. There's so much content already available at their doorstep, and they are adding so much new stuff on a regular basis. It's just absolutely amazing and brilliant, pun seriously intended, what they can do for you and your STEM education. So check it out today and become smarter every day. And I thank you guys for watching, and I hope you did enjoy today's improvisation, semi-improvisation. I really did like this problem, and I didn't think at this one point right here that it could turn into what it did, and I hope I got it right. I thank you guys for watching, and up until the next video, I'm wishing you guys a flammable day. See ya.